Good. So welcome everyone to this month's edition of Tech Talk. I'm going to do something a little bit different than what I've been doing for the last year or so. I've been trying to be technology agnostic and just talk about algorithms and principles and how things work and what things do and how we accomplish this, that, and the other thing. But this time, I received my cnWave lab, and I'm actually very excited about this. This is very definitely a different way to deliver broadband to subscribers, and I'm pretty excited about it. So I thought that for the next little while here, that we would delve into cnWave and just look at the mechanics and the how-tos and that sort of thing. This month, I thought that we would do a lab setup, a small network setup using the onboard end-to-end controller. Next month, we'll do the external end-to-end controller. It's a little more complex because it's got some IP version 6 connectivity that you need to configure. Make sure that it works, but once you have it, it is okay. It works. It works good, and then maybe for a third session later on here, we'll do a network plan and link planner. That has it's a bit of a complex. To do it right, it's a bit of a complex beastie, and so I thought that would be maybe what we would do for the next few sessions. Anyway, let's get going with cnWave here. All right. So the product line consists of 3 products: V5000, 3000, and 1000 at this very moment. These devices are all PoE powered. The V5000 and 3000 have 10G and 10 gig and 1 gig interfaces on it. The system forms IP version 6 links between the nodes. That's how the nodes connect together. And today we're going to do IP version 6 the easy way. And we're also going to show off the layer 2 GRE tunneling. The IP version 4 configuration then is what we're actually going to use to make our devices talk to each other and to deliver services to some end devices. Got some Raspberry Pis and some other things that are hanging off the end of a couple of my connection nodes and or client nodes, and we'll see how that goes. And one of the cool things about this is that all of these devices can be a distribution node. The V5000 exclusively is a distribution node, but the 3000 and the 1000, they could be a distribution node or they can be a connection or a client node. And so depending on how you need to arrange this network, it is incredibly flexible. Now, one of the things about this is 60 gigahertz. This is a millimeter wave. This is, it's fairly high power, but it is line of sight only, absolutely line of sight only. You put your hand in front of a V1000 and I can break the link. I can stop the signal. So it has to be line of sight. It has to, we also have to make sure that we've got enough margin in our links so that we can compensate for rain, for whatever it is. It all goes to the maximum range. So in our rain zone here in most of Canada, the ranges that we can talk about are in the order of 200 to 500-600 meters for the V5000 to 1,200 meters, or 3,000 maybe can go up to 500 meters maybe. And depending on where you're actually installing this, and they can be run in point-to-point mode. Also, client nodes can run in point-to-point mode. So I could have 2 V3000s in point-to-point mode, managed exactly the same way that we're going to go through today in the demo, and I can put those about 1 kilometer apart here in here in Western Canada anyways, and where it's drier, we can go farther. And of course, where it's wetter, we have to limit the range so that we have the margin that we can, you know, keep the links working. And all of this is managed by an E2E or end-to-end controller. And we're going to enable the controller today in the V5000 and use it from there. But I could use it in the V3000, or I could manage the controller in a V1000 if I wanted to do that. I've tried it all, and whether the controller's on the V1000 or the V5000, it doesn't make any difference to the network. As long as it can see the nodes, then it can manage everything that you're going to configure and build. So we're going to start with the V5000 in factory default mode. The steps are going to be enable and configure the E2E controller. And while we're doing that, we're also going to connect it to CN Maestro. Now, at the moment, we have to use beta version 3.04. If you look at the bottom of your monitor page or your sign-in page with CN Maestro, you'll see that the regular version is 3.03. So this 3.04 right now has the fixins for the cnWave product. Eventually, this beta version of 3.04 is going to become the standard version, and then Maestro will configure into. cnWave will configure into Maestro just like any other 450 or APMP or whatever product it happens to be that your CN Pilot, whatever the case. All right, so then once we have that configured, we are going to create our sites. This is the steps to build the network. You create sites, and then we add nodes to sites. So sites are created at a geographical location. The nodes are the MAC addresses from the equipment's perspective that we add to the site. So we tell the node configured to the site tells us what machine is going to be there. And then we add links between the nodes. And so that's the 3 steps. And there's some configuration that needs to go along for each one in the way. And being that we're in a lab situation at this moment, which is what a lot of people are going to be doing in the next little while with their cnWave, I'm going to specifically talk about the configuration that you need for close-in connection, close-in link lengths, like less than 25-meter link lengths between client nodes or distribution node and client node. All right, so on the configuration of the E2E controller, we're going to enable it on the V5000. We are going to enable the layer 2 tunneling. We're going to have the V5000 generate the IP version 6 prefix seed, but we're going to be doing IP version 4 addressing. And then we're going to take a look at the interfaces, and we're going to declare one of the interfaces as the point of presence interface, so the network feed into the network. We can have multiple pops in a cnWave network. In my lab, of course, I have one at this moment, and that's all that I want is one network interface onto the cnWave network. So that's we're going to do that. We've got, I'll show you as we get going along here, but I've got a fiber connection, a 10 gig fiber connection into the V5000. I also have a Cat5 connection into the V5000, which we're going to initially use to do the configuration. And then I've got a router and a laptop connected to the auxiliary out connection, which is essentially just a bridge between whatever we decide is the input and the pop and the so I've got a laptop that's connected up there as well, and it's going to be one of my iPerf servers that we use at the end of this demo. We're going to test and show some throughput across the network. All right, so as we're looking at a V5000, a few things that we have to consider. One of them is of course, the azimuth or the orientation. Now, in a lab setup that I configured yesterday, helped a customer through yesterday, He had just taken and set the V5000 down on a desk and the V1000 down on another table. And then we tried to connect it together, and lo and behold, it wouldn't work. So why wouldn't it work? It was because the azimuths, the 60 gigahertz, the azimuth, even with beamforming operating on the system, the azimuths are still pretty critical. So you have to have the V5000 oriented properly, and the orientation is divided up just the way we see here. When you're looking down at the unit, or if you're standing behind it, where it's mounted on a pipe, sector 1 is to your right and sector 2 is to your left. So looking down or in the front of it like this, now from this view, sector 1 is on the left and sector 2 is on the right. Got to keep that straight. And if we try to connect something in the null that's at the back there, where the 240-degree sectors do not cover, it will not connect. If you turn that around, you cannot take no matter how close you put it, you can't put a client node in that null space in there. It just simply will not connect. It'll sit there and it'll try. You'll see it trying to ignite. We'll see what ignition is, and you'll see that, but nothing will happen. As far as the radio parameter goes, we have 3 parameters that we have to set. We have to, of course, pick a channel, and default is channel 2, but we can pick any one of the 4 channels. In the 60 gigahertz band, there are 4 channels that are 2 gigahertz wide, 2.016 gigahertz wide. So we have 4 channels. We have a polarity. This polarity is kind of I find it a strange term, because what it really means, we think of polarity, we radio guys think of vertical and horizontal, or electrical guys think of positive and negative. But in fact, what this means, as far as cnWave is concerned, is polarity is the order of transmit and receive of the TDD split. So even has, let's say, has the transmit first, the receive second. Odd has the receive first and the transmit second. So therefore, when we're configuring links, we need to have the sector of the V5000. In our case here, we're connecting V1000s to the 5000. We have to have the V5000 in, let's say, even, which is what we're going to do, and we have to have the polarity of the V1000s as odd, so that they will connect and pass traffic. There are a couple other modes in there too, hybrid, and which is a split. And in cases where we have an even number of distribution nodes on a network, we can be even odd, even odd, even odd, and join them up, and everybody is happy, because even of this V1000 or V5000 is connected to, let's say, sector 1 of another V5000, and it will be configured odd. And Cambium recommends that both sectors be configured on the same channel. Both sectors of the V5000 are the same polarity, but each adjacent device connected to it has got to be the opposite polarity. So that's part of the planning of the network that we have to do. And then finally, we have these GoLay codes. The GoLay code is like a precode. So when you have, if think about a mesh environment, you've got RF all over the place. Devices can see the signal from multiple devices, and we have to have some method of having the receiver determine what's my data and what's not my data. And so what we do is this 24-bit GoLay code is the mechanism that was selected to do this. So the GoLay code, the way the cnWave behaves is that when the GoLay code is correct on the signal that it's receiving. In other words, my GoLay code for my receiver is 1. My GoLay code coming from the transmitter side is 1. This is my data. I'm going to decode it. If the GoLay code was 2 coming from the transmit side, and I was expecting GoLay code of 1, then I'm going to throw that frame away. And in fact, when we set up the link, if we have some time in this demo, I'll set the GoLay codes wrong, and we'll see the link won't mesh up. The GoLay codes, when they're set properly, of course, the link comes up right away. And in our little case here, if I'm going to put both sectors on the same channel that Cambium recommends, then the GoLay codes by default are the same. They're both GoLay code 1. So what'll happen then is, yes, I can connect up my couple of client nodes, one on each sector, but the link will come and go and come and go and come, and it will be very unstable until I get the GoLay code set right. So it will connect, but the GoLay codes have to be right. So all of this configuration that we're going to do is actually in the E2E controller. So I don't actually log into any of my client devices. I log into this V5000 simply because it's the POP and it's the one that's running my E2E controller. And so I do all my configuration from there. That's really handy about this network. And so as far as management goes, I don't need to worry about the address, the IP address in the subscriber units. If I don't want to log into them directly, I can log into the E2E converter, and I can talk to all of my my devices out in the field if that's what I want to do. So a couple other things. They have a short range mode here for let me just do that for a minute. And I've got a short range mode for hang on one second. It's in the voicemail. There we go. All right. So I've got a short range for lab use here. What it does is it disables the beamforming. So when I'm at less than 25 meters, I don't need the beamforming, so I turn it off. I don't want to waste any of the over-the-air protocol with it with the beamforming on. And I might need to disable the GPS. If in my case, I'm lucky, I have a window right by the V5000 and I can get GPS signal. If I were in a place where I did not have a window to receive the GPS signal, then I would disable the GPS. All right. So we're going to see that we have a topology, and we use this topology to take and create our sites. We add the nodes to each site, and then, as I said, we build links. And so this is an example of a little network that I had before. So we're going to build two, or maybe we'll build all three of these links in once we get the first one up. It's pretty easy to build the other two. All right. So here's some of the parameters of the V5000. I just put them in here in case somebody wants to get this short little slide deck, and I just put the slides in here for reference. But we're going to see all of this in the actual device. Here's a page of cnMaestro that you can see that it's the beta version. You can see that this is my account. This is my cnMaestro account. I've got the network kind of forms up like any other network does here. I've got sites, and then inside of the site, I've got a node, and overall the MAC address of the E2E converter. Right there, you can see that the E2E converter, controller, I should say, not converter, controller, and the MAC address of my V5000 are the same. So you can see where it is. And off we go to the demo. So let me put that away and let me bring this up. Okay, so when the unit is factory defaulted, the IP address is 169.254.1.1. So I have factory defaulted my V5000 already, and so here I am. I'm pinging 169.254.1.1. I configured my computer to .1.100, and I could make it anything other than .1 as the last digit of the IP address, and it'll talk just fine. So when I go to log in, it's Cambium standard. I haven't changed the at this moment. The username and password are going to be admin and admin, and bingo, I bring it up. Okay, so as we can see, I've got two sectors here. I've got no links. I have on my dashboard here. This channel is going to be bouncing around because it's actually looking for, at this moment, it's scanning for connection or client nodes, and it can't find any. because we don't have any configured. So the screen updates here, the window updates about every 10 seconds or so, and we'll see that when it updates that, yeah, there, see jump channels, went to something else. All right, so first step in all of this, I go to the E2E controller, onboard E2E controller, and I'm going to enable it. So I press the enable button. And then it lands me up with some parameters that it wants me to do. So let's give it a 50.866.1305. We'll give it a latitude. Oops, not 144, 114. Okay. What's my? It's 67. 1915. All right, but we're gonna, of course, once the GPS discovers it, it's going to take and assume whatever the Latin long is exactly of my location here. Now, IP addresses. I want to be able to get this device from my network, so therefore I want to take and put it in the subnet that I'm using here, which happens to be 172.29.128, and I'm going to configure this to 240. I'm going to take and give this 24-bit subnet mask, and my gateway for this particular subnet is 172.29.128.254. All right. So controller setting. I'm going to enable the controller. I'm going to manage the IP version 6 addresses from center of the network, and then I'm going to take and enable my connection to CN Maestro. So the URL, I'm sorry, is https cloud.cambiumnetworks.com. My cambium ID is cnWave _DC, happens to be, and my onboarding key is one of my fabulous super secret passwords, and I enable the controller. So it's going to go and turn it on. During this process, it knows it's a V5000, so it's going to create the default node. It's configuring remote management, and it might reboot at the end of this. I'm not exactly sure. I don't remember. Going to reboot a few times as we're going through this configuration. So there's a little bit of hurry up and wait time here. All right. If anybody has has any questions while we're waiting for this thing to come up, then go ahead and ask. Now we pop back to this page again. That's because I changed the IP address to an address in my network, so it's no longer I can no longer access it here on 169.254.1.1 because of the fact that that it is something different now. So it was 40, so HTTPS not secure 172.29.128.40 should be it, and boom, there it is. Okay, so here I am back at our login, admin. Okay, so I've got no links up. I have one node online. There it is, green in the middle of my map. Let's put a name on it. There it is. That's exactly what we've done so far. Okay, so if I go to configuration here right now of my network here, I am going to enable my layer 2 bridging. This gives me of course, the ability to use IP version 4 or IP version 6 on the rest of the network. I'm going to make sure that my prefix allocation is centralized, and I will click the generate link there, and it generates me a 64-bit address based on this 56-bit prefix. So that's IP version 6 theory in a nutshell here, is that every one of my devices that I connect to this network are going to have an IP address, a IP version 6 address that starts off with this FD00 and C Charlie Echo Delta, and so on, and they're going to be 64 bits in length. The reason that 64 bits is picked is because that is the subnet mask length that can be advertised by SLAAC. SLAAC is the acronym in IP version 6 for the automatic configuration. The ACK part at the end of that is automatic configuration. All right, set the country code to Canada. There we are. We're going to enable channel 2. That's fine. I'm going to use, since I'm using layer 2, I can use well, let's say OpenDNS, right? 208, I should say, 208.67.222.222, and let's give a secondary one also. So 208.67.220.220. Okay, our time zone. We're going to be America, Denver, which is Mountain Time, which what I happen to be in. And the pool that we're going to use is ca.pool.ntp.org. And I can use time.google.com as a secondary, whatever it is I want to do. All right. So, and you can see there the IP version 6 configuration is by SLAAC, is there by default. And if I hit submit, this is going to tell me that it's going to give me a warning. Configuration change will result in all nodes getting rebooted. Okay. So here again, we get to watch paint dry for a minute. And let me get rid of it. Oops, Control C. There we go. And let me just ping our new address here: 172.29.128.40. And it's going to be up for a bit, but it will time out. And when it comes back, then I will take and be able to re-log into this device. There it is. There's our timeout. So now we're in the middle of the reboot process. Too bad on a live webinar, I couldn't fast forward through this and then just get to the next spot, but no, have to watch paint dry. And it's slowly coming back. The Ethernet port came live again. And there we're up. Okay. Let me put this down and let's log back in here again. And we're going to have to go through this one more time, actually, by the time that we're finished here. All right. So this will come up in a second here. And let me go back to configuration and let me go to nodes just for a moment. Now, here's the IP addresses that I set in there before. I'm going to use static routing. My POP interface, I want it to be my SFP plus actually. The network connection is I want it to be on my 10 gig connection, not on my Cat5. The main is Cat5. The auxiliary is a 1 gig interface. Also, the main is a 10 gig interface. But it will throttle down to 1 gig, and of course the SFP is 10. So I'm going to enable all 3 of my ports. I am not going to restrict my layer 2 bridging. My network's too small to do that. I am not turning on the auxiliary PoE power. If I were going to power a device that needed the PoE, I could turn PoE on here and of course feed it that way. I do not have multiple POPs in my network, so therefore I don't have to run the OpenR routing protocol But if I did, I would pick the interface that, of course, that would be on. That would be the SFP as well. And then my out of band interface. I can manage this device from one of the other ports if I wanted to do that. If I wanted to enable the main port or the auxiliary port, for example, as the out of band interface, it would give me the opportunity to enter an IP address for that particular port, and away I go. So I don't want that at this moment. I'm going to disable that again, and I'm going to press submit. And I think because I changed the device, it's going to say, "Will trigger a reboot. Do you want to proceed?" Yes, I do. So again, we can watch this thing go for a minute, time out, and then come back. So while we're waiting here, we had our first rain in about a month here in Calgary, from 2 nights ago through to about 4 o'clock yesterday afternoon, about 18 hours. It was very, very nice. It's very clean and it smells very good outside compared to all the smoke that has it's been so thick at times that we hardly had a kilometer visibility around here. So it's very nice to have it all cleaned up a little bit for a while, and the temperature, instead of being in the 30s, down in the Celsius, down in the 15s or the teens, upper teens today. It'd be very nice. All right. He is going to quit. Maybe it's fast enough. Let's just try. Let's see what's going on here. If it does drop out, then yeah, it looks like the replies are still coming. All right, so let's see. All right, let's try adding a site. So we've got one site. We've got the site that I configured right off the bat here when I enabled the EDE controller, and then let's add another one. So I have a couple of speaker poles that I have my V1000s mounted on. So let's call one speaker tree left. All right, I managed some lats and longs for these things. So 866 1571. My longitude is going to be -114, not 144. Did that again, and 067 6116. My altitude is going to be around 1,000 meters. My accuracy I don't care about, but that's 50 meters. That accuracy is how close am I, and 50 meters is good enough for this right now. So there, I added a site. Successful. All right. So now I'm going to take and add a node to that site. So I have the V5000 node is already configured. I'm going to add a new node now. So it comes up with this dialog box, and I'm going to call it speaker tree left. I'm going to use speaker tree left as the site. Is it a POP node? No. It is a connection node though, and I need to identify it by the MAC address. Let me stop our little sing-song here. All right, the interface is coming up and down. All right, so 000456, and speaker tree left is 8B1A79. 8B:1A:79. All right, there we are. V1000 platform. It's roughly sitting in a pointed at 90 degrees, give or take, and its elevation we'll assume is 1,000 as well. And away we go. So there we are. So we've got a successful node configuration. All right, so the final is I want to link these together. So it's a wireless link. My A node, I can make my A node the V5000, and it's got 2 MAC addresses. One is for sector 1 and sector 2. Now my left is actually going to be connected to sector 2, my left pole. Now my Z node is going to be speaker tree left, and it's only got, of course, 1 radio in it, so it only has 1 MAC, and the system knows that. So I'll hit save, and I have now added a link. So this link will begin to there's an ignition attempt. It tried to come up. So there might be some parameters that we don't have right here in order for this link to, oh, there it came up. Our link is up. So now there's a control. So the Raspberry Pi that's on the end of that link should be 172.29.128.104, I think. Take a wild shot in the dark. No, it might have got a different DHCP address. That's all right. We got to go through some more configuration anyways. I was hoping that it would be that easy, but it's often not. But all right, so let's go through the we've gone through the networking configuration. So we have that page. Now the radio, we have we need to set it for short range. We've got nothing connected to sector 1. So of course it doesn't have any default information in that. When we connect the other node to sector 1, then it's going to have some data in there. But in fact, right now we're on sector 2, and our auto configuration is channel 2, and we're even. That's fine. I'm okay with that. And our GOLE code is 2 for receive and 2 for transmit. I can separate those. I can make them different if I want to do that. And of course, I have GPS signal, so I'm not going to defeat the GPS. So I'll click submit because I made the change to short range, and it comes up and it says successfully set node override. Now let's go to the configuration that's in the E2E controller for the device in the field. So I want to set it for short range, and we can see here that my auto configuration is channel 2. My polarity is odd. So here the even in the 5000 is talking to the odd in the 1000, and my GOLE code is 2. So that is exactly the same. So that is why it connected up. So let's just submit that. And we're good there. And let me go to networking out in the radio here. So we connected, even though our address is the default. Let me bring it into the network here so that we can do something with it. So 172.29.128. We'll call this one 50. And 255.0 for 24-bit subnet mask, and the gateway 172.29.128.254. All right, and I'm using Ethernet, the main Ethernet port on that. So there, I successfully set the node overrides. Okay. Yeah, let's go back. Let me just go back to my nodes, and I'll bet you no, SFP is good. Okay. All right, let's open up the router, and let's see what address my little Pi has gotten down there. So let's go here, let's go there, and MicroTik in my lab is a fun little device. All right, there we are. Okay, and we're at my DHCP leases, and so my there's my the Raspberry Pi is definitely is 104, so I should be able to ping it. And there it is. All right. So the difference here was setting it up for short node. That my receivers were at overload when it was trying to use work its way down to from full power down to the power level that it's at here. So let me just put these to sleep. Let's look at some statistics here now. All right, so there's when the link is up, it has two directions. You see both directions. See RSSI, you see signal to noise ratio. The modulation level here is 10 and 9, and it'll flip back and forth in my office here because I got lots of reflections, lots of issue. It's not a very pure environment at this very moment. Maximum modulation level is 12. See the EIRP, by setting it down there, I limited the EIRP to 13 dBm. So I put it essentially in low power mode, and it has a number of scan beams that it's taken and done. There's some, a few errors on the interface, but nevertheless, there's the frames. I have Ethernet statistics, and I can look at the statistics on the SFP or the main, which is the one I was talking to the device through, or the auxiliary port, which is where my laptop is connected. So the SFP right there. All right, GPS. I'm at a three-dimensional fix. And you can see from my window here, I got 12 satellites, and there's my actual lat and long and my actual altitude. Now here we see the radio. We see that my two radios in my V5000 are synchronized by GPS, and my speaker tree radio is synchronized by RF from the V5000. So the V5000 is the timing source on the network. I have some RF throughput on sector 2, and don't have anything on 1 because I have nothing connected to it at this moment. Now, true to Cambium's form, they come up with graphs for the performance, so you can see what's going on here. Interesting thing about a lab is that you see the modulation levels jump back and forth for links in both directions. That's me getting up from my desk and walking across my office, and sitting down again as the system's in operation. As it goes around and through me, the link doesn't break, but but I change modulation levels as I move around in my office. What else can I show you here? As you get going, the system will have more meaningful information as you get real traffic through it. On the engineering performance page, statistics page, I should say, you can see the memory utilization, the CPU utilization, and temperatures, things like that are there. And if I were using border gate protocol, I would have some BGP information here, but since I'm just doing static routing, of course, I'm not at this moment, so there is no BGP. And essentially, that's it. As far as tools go, from the radio itself, from the V5000 that I'm logged into here, I can do a factory reset. That's the only real tool that I have here in the tool list. On the map, there's show the names. So there's speaker tree, and there's my V5000 and my street. Let me back this out a little bit. So that's where I kind of put it here. Now, in the unit itself, I did have, but I don't have at the moment. If you're going to do any software update, the units come with image version 1.0 installed, and 1.1 is the current version. So you go to Cambium support site, download the latest image. They're called IMGs, image, and you install them here in the E2E controller. So I can upload the image. It'll bring up a dialog box. I download them to my computer, and then I can upload them to the E2E from my computer, and away I go. And I think I probably have them here somewhere. Yeah, it doesn't matter. I would download them fresh again anyways if I were going to take and update my firmware. And I would put them in here, and then I can initiate node upgrades from my EDE controller. I do not actually have to log into my field devices or anything else. So let's quickly here. Let's just let's go do one more here. Let's add the my what I call my speaker tree right. So let's go back to sites, and I'm going to call it speaker tree. Whoops, yeah, right. All right, my latitude for it is going to be 50.866 again, 4009, and my longitude is -114.0677. 404. All right, my altitude here again is around 1,000, and bingo, I created site. Okay, now I'm going to add a node to that. So I add a new node. I'm going to call it speaker tree right. And the site, of course, is the same site. It is going to be a connection node. It is not a distribution node. Not for the sake of our little demo here, anyways. And I'm going to take and speaker tree STR right there, 8B0F, 8B0F, BC is the MAC address that's in the device itself, and it's at about it's about 120 degrees or something like that. And again, our elevation. All right, there it is. Now let's form up another link. And so it's a wireless link, and I'm going from speaker tree right to node the 5000, but I want to go to sector 1, and I'm going to save it. All right, so there's my link. I probably need to go to the configuration and set the configuration for short range. I'm not sure that it's actually set there. Now let's see what happened. I think my Gole codes are wrong, because I brought when the sector 1 or the sector 2 link tried to come up, it brought down the sector 1 link as well. So let's have a look at that. This is a real typical. I think this is going to be a real typical problem in that you need to do the configuration of your V5000s first and go from there. So let's go back to radio here. All right, so on sector 1, we're even, which is fine, and we're Gole code 2. Look at that. So it's the same. So now let me make this something else. So let's go to Gole code 1, and I'll hit submit. Okay, and then let me go to the configuration for speaker tree right, and oops, I'm going to override it, and I'm going to make it Gole code 1, and I'm going to submit it, and when it joins, and I'm going to set short range. There we are. So now when this link comes back up, then it should be let's go back to our topology. Let's go back to the links, and let's see it fire. The ignition. So it takes a couple of ignition attempts to actually push that configuration down there. And then when the link comes up, it's ready to pass traffic. And there we are. And so we have a pair of working links. Now, if we go to statistics, then here we go. We got uplink and downlink from speaker tree left. I can spread this out a little bit so you can see. And I got uplink and downlink from speaker tree right. And we've got some RSSI values. We've got some SANAR values. This will update, I think, because it shouldn't be negative. I don't believe it should be negative. The fact that we've got a link tells me that that just hasn't updated yet. There we are. It's going to come up again. It's going to end up being around the -44 as well. And as it takes and sorts itself out here, and away it goes. So on the end of that, if I go to my router, I have a little Windows ARM box that's called that I've got called here V-Link. Let me show up in here. Come on, you. Let's take a second to get sorted out here. Let's be. No, we'll leave that for a moment. Okay, just for a moment. All right, let's just for giggles, let's log into .104. Okay, there we are. So I've SSH'd into the Raspberry Pi that's on the end of our speaker tree left link, and let me do iperf-c 172.29.128.89. I think should be it. And let's see the results every 5 seconds. Excuse me. Let's set the time for 30 seconds. So 30, and let's do both directions at the same time. Let's see what happens here. So there we are. So talk to this laptop that I've got sitting outside of the auxiliary port, and there's my throughput. That the upper one is uplink, and the bottom one is downlink. And so this is what iPerf is telling me, that we can flow across this link right at this very moment. So I'm limited by my gigi interfaces, and but roughly I'm at roughly around 900 megabits performance to this unit. So that is essentially that's cnWave, and I kind of hope you enjoyed the little demo here. I don't see any questions in the chat box, but at any rate, you can, if you have questions and want a little bit more information about what we went over today, or to you know, arrange anything that you want to you might want me to answer, just send an email to support at mbsiwave.com or at marketing@mbsiwave.com, and either one will get to me, and you'll be able to we'll get together, and whatever issue you've got with the cnWave product, I'm sure that we can help you through it. There's a number of configuration parameters here that I did not talk about today, that as we go along, and as we you know, get more into the weeds with this product, then I'll be happy to talk about that. You noticed when we were setting up the links, there was a wired and a wireless. What's a wired link? Well, we don't have time to demonstrate a wired link today, but essentially, let's suppose I'm coming to one side of a building with a CN, but I've got to connect to a network that's available on the other side of the building, not on this side of the building. Well, I could cable them together through a switch, and I can call the connection from one CN to the other CN as a wired link, and then it behaves as part of the mesh. And so I have lots and lots of different ways that I can, of course, configure this network and just get it done. So I appreciate the time that you spent today, and look forward to going over a little bit more in detail next month. So at that rate, Nicole, I think that let's call it a day.
Sounds great, Dave. Thank you for a great session.
All right, we'll talk to everybody soon.